Okay, this right here is a demonstration of Young's experiment. Young's experiment is essentially the demonstration that definitively shows that light is a wave. The actual experiment was performed by an Englishman named Thomas Young in the early 19th century. The experiment is designed to measure the wavelength associated with light. Okay, so I have right here one of my demonstration laboratory lasers, and what I'm doing is I'm shining the laser itself onto this card. And then if you look carefully where the laser spot is, you'll notice that it's shining on two very closely spaced holes, two very closely spaced vertical slits. Now, if you take light and you shine it onto two holes, what would you ultimately expect to see in the background? Well, maybe perhaps two spots of light. That's not the case, however. Instead, you're going to see an interference pattern. Now, to see the interference pattern, I have to walk to the front of the room here, and I, of course, have to turn off the lights as I do. So bear with me as I do. Okay, and then right here on a piece of paper taped to the whiteboard is the interference pattern itself. So notice that you do not see two spots of light. Instead, you see an alternating series of what are referred to as bright and dark fringes. The bright fringes are antinodes. They are regions of total constructive interference that are formed exactly the same way as they are in the two-source interference situation that we saw back in the previous unit with the ripple tank. And then in between the bright fringes are what are called dark fringes. The dark fringes are nodes. Those are regions of total destructive interference where the light waves, in this case, completely cancel each other out. So like you do in the ripple tank with two-source interference, we see here an alternating pattern of nodes and antinodes, bright and dark fringes. Okay, the center of the pattern is called the central maximum. And then as you can see, the pattern begins to dim from there. So I'm going to go ahead and pause this here, and then I'll explain the situation in lecture.